Hi, my name is Bryan Foutch, and this is a demo of a tool we've used to help teach you a little bit more about how a traffic intersection works. We're going to load up a simulation real quick. The simulation was output by a third-party piece of software called VISSIM, which is a traffic simulator. And so basically what you have here with traffic is you have a flow of vehicles, and eventually vehicles need to cross paths. And where they do that, or when they cross paths, is called an intersection. The intersection is what this demonstrates. There's two main things that an intersection needs to consider. It needs to consider the safety of the vehicles to safely pass through, and also to do that in an efficient manner. So some components of an intersection are: an intersection has lanes, and lanes are just the separate directions that traffic wants to flow. In the traffic engineering world, lanes are called phases. Now, a standard traffic intersection like we have here contains 8 phases. Every phase is in either one of two states. It's either active or it's conflicting. Now, it's easy to tell because active phases have a green or a yellow light, while the conflicting phases have a red light. Now, like I said, each phase has to take turns. Now let's look at how the intersection decides whose turn it is. So there's a basic flow of events here. The first thing that happens is we have user arrival, and this is just the cars in general approaching the intersection. That user arrival needs to be detected by the intersection, and this happens in a very small region where the intersection uses detective systems to see the approaching vehicles. Once detection occurs, it's passed on to a controller. Now there's one controller for the entire intersection, and this controller pays attention to all the detectors and coordinates whose turn it is. And when it's made its decision, it outputs that to the display, and that's where you get your red or yellow or green lights. So the purpose of the controller is to keep traffic flowing as efficiently as possible. This means that it needs to pay attention to things like whether or not a phase has heavy traffic flow or slow traffic flow, or if there's other people waiting on conflicting phases to have a turn. The controller uses a series of timers to coordinate this. 3 main timers it uses are the maximum green timer, the minimum green timer, and the vehicle extension timer, which I'm going to refer to as the gap timer for the rest of this demo. The min-green timer starts when the phase becomes active. Now the light cannot change until this timer is finished. Now the gap timer measures how heavy the flow of traffic is, and if both the gap timer and the minimum timer reach 0, this means that the traffic flow isn't heavy enough, and here we see that's happened at this point. The controller decides, when this happens, the controller decides that it's time to give another phase a turn. Looking at our data, we can see how the gap timer works. Each time a vehicle is detected, as we can show here in the simulation, the gap timer resets to its maximum, and it's held there the length of the detection. Now we can see that this has happened consistently, as every time a vehicle passes through our detector, our gap timer resets back up to its maximum. So if you have a really heavy flow of traffic in an active phase, that gap timer is never going to be allowed to reach 0. So in this situation, you need something else to end the phase, and what we use is the maximum green timer. The maximum green timer is critical for this situation. It's used to end the phase even if traffic flow is heavy. It listens for detections from conflicting phases, and if it receives one, it starts a countdown that will ultimately end the phase. So as you can see, all of these 3 timers work together to create a dynamic intersection that listens to traffic flow, that listens to cars waiting for their turn, and does its best to give us a dynamic system that keeps us safe but also allows us to efficiently travel to our destination.